Hello, everyone. So, how many of you are front-end engineers? You work mostly on the front end. Okay. How many of you back-end engineers? Okay, more, about 60%. Cool, cool, cool. How many of you think they know Node.js, but are still here? Okay, so you have enough time to go to the next room. So, if you have computers, if you're not tired already from all this amazing information, you can code along with me, and because I have some code examples, or you can just relax and know that all the slides are on the GitHub. So, yeah, take a picture. It's there. It's all open source. Okay. So, just to remind you why we're here and why it's good to know such thing as Node.js and JavaScript. So, generally, software is kind of becoming everywhere. Our lives becoming digital. So, by building better software, we can actually improve lives of other people. A little bit about myself. She already introduced me, so I will skip through the slides faster. Some of my books, Practical Node and ProExpress, we have them here. My publisher, Apress, they kindly provided the books, so we will do the giveaways and signing. You can find me on Twitter and blog, and some of the other highlights. I worked at Storyfy and DocuSign, early users of Node.js, so I know what I'm talking about, more or less. Capital One, it's famous for its Viking commercials. It's one of the top 10 US banks. I promise I'm not going to have a lot of gifts, only 2 more. Okay, so let's start with basics. First of all, it's like, why do we even want to use Node.js, right? Because we might have people completely new to Node.js. So there are typically 2 categories of systems. One is input and output bound, and another is CPU bound. So when we're building web applications, we're usually working with input and output bound systems. So what is input and output? It could be writing to the database, making a request to a server or a third-party service, or doing something else, which is usually takes a lot of time just for the waiting for that process. So Node.js has the thing it's called non-blocking I/O, or non-blocking input and output. Why this is good? So when we're working with Node.js, and usually we're building web servers, we might have some clients making requests. So under the hood of Node.js, we have event loop, which was borrowed from Google Chrome V8 engine. So that event loop is always looking for things to execute, and then it delegates the actual jobs, the actual processes, to some other systems. For example, file system or database, etc. So when the delegation happens, event loop also passes the callback, which is typically some JavaScript or Node.js code. And when the system is done, it's over, it's finished, that callback is executed. And usually that callback has the code to send back the data to the client, if we're talking about web servers. So how many of you are Java developers or started with Java? Okay, so even if you're not hardcore Java developer, you kind of guess what is happening here. There is a sleep method, and the key here, probably this is the most important piece in like the whole presentation. The key here is that Java process will be put into, so to say, sleep. So nothing will be executed until that 1 second passes. So 1,000 milliseconds or 1 second blocks the entire process. Okay. Contrast that with this Node.js code, where we're scheduling the process in the future by using a callback. So that function, instead of a set timeout, it's not executed right away. It will be executed in the future. So from step 1, we skip right to the step 2. Then 1 second passes, and we would see step 3. So why this is good? Because we could execute more code while the waiting is happening. So the waiting is not actually sleeping, it's just scheduling in the future. So we would see step 1, step 2, then we would see step 4, and then we would see after 1000 milliseconds, step 3 and step 5. So this is probably the most important piece from this whole presentation. Node.js allows you to write faster applications, typically, because we're utilizing that idle waiting time. So let's talk about web servers a little bit. So this is how we would write a web server schematically, of course, just a diagram, using some of those blocking I/O systems like Python, Ruby, Java, etc. Each subsequent request would be blocked by the previous request. So you have the queue, and they have to wait in that queue. I always like to give this analogy of a coffee shop. You go to a coffee shop and you order your drink. He or she, the barista, the cashier at the register, they would take your order, they would take your money, and they would turn around and make you a drink. And usually that leads to long lines. People are waiting in line because each person before you has to order the drink and wait for that drink, right? So you have unhappy customers. The line is blocked, your typical blocking input and output system. Now, let's take a look how things are in Node.js. So we have event loop again, and event loop delegates the processes to others underlying systems. So event loop is almost never blocked. It's almost never blocked, and that's a good thing. And it's also single-threaded. We will talk about it in the next slides. But basically, going back to our coffee shop analogy, this is how Starbucks works, and maybe Dunkin' Donuts, which I've heard people like in Iceland. So people are happy they're sitting at the tables because it's asynchronous. We have this non-blocking input and output system implemented. So you go, order your drink, they write down your name, and or maybe they give you a number, and then you go back to your table and you continue working on your JavaScript application, and they call you, you go back and get your drink, right? So people are happy, we don't have a line, and also this process tends to be better at scaling, because the only way you can actually scale the blocking system by increasing the number of threads or increasing the number of registers, the cache registers. That will increase the number of lines. But in this example, you can increase the number of workers. So multi-threading, it's not necessarily a great thing. Sometimes it can blow up in your face, especially if you don't know how to use it. So it comes with complexity, and it was born out of the necessity how you would scale a blocking system, right? So the blocking system, they have to be multi-threaded. In Node.js, it's a single-threaded system. So it eliminates complexities such as synchronizing the data between threads, deadlocks, racing conditions, etc. But it's still possible to write blocking code in Node.js. So by just knowing that Node.js has the non-blocking I/O, it's still not going to prevent developers from writing blocking code. Let's take a look at this example. And you can run, there is a file blocking.js, so you can just go into your terminal and execute that file once you get my source code. And I get anywhere from 100 milliseconds to 1000 milliseconds. Obviously, most of the times we don't get the blocking code, which is obvious, which is like a for loop. This blocking code is buried inside of the module. I know that module, that's how, so the way to know that it's asynchronous, basically, you need either to read the documentation or read the source code. In this case, FS, the naming convention, it has the word sync in it. So we know that it's a synchronous module by looking at it. Another dead giveaway sign is that the content will be available right there on the next line. So I can assign var and then the result of read file sync, and I can console log that. So we will go from top to bottom, just as in any other traditional programming language, in a synchronous language. So it's very easy to reason about, but this would not be very efficient code. This is much more efficient code. It's also in Node.js, but now we're using function which is read file, not read file sync. And with this file, we're using callbacks. So the trick here is that the data would not be available on the next line. So console log hello Ruby would not have the content of the file available. The content of the file will be available in the future when the callback is happening. And your result might vary. So first you might get the accounts or IP addresses from ips.txt, or you might get IPs first, depending on what file is larger, right? So we're executing them in parallel. Parallel and concurrency, they're different terms, but when it comes to Node.js, they're usually interchangeable. So Node.js is typically much, much faster than other platforms and languages because of this input optimization, input and output optimization. But let's be honest, how many of you actually hit the bottleneck when it comes to performance? Personally, I don't experience that problem. If I have that problem, I can add RAM, I can add CPU, I can add workers. It's cheaper to scale than it used to be 10 years ago. So I'm not building the next Facebook or Google. For me, my personal Node.js benefit, and a lot of other developers also share this, is that we can use JavaScript. So we have one language to rule basically the entire stack. We can think faster, we can reuse code. If I'm using lodash or underscore on the browser, I can use that on the server as well. And also, if I'm using the same API, the same interface all over the stack, I'm learning quicker. I don't need to refer to the documentation that much. So the good thing about Node.js is that most of these classes, these objects, they're available as is, right? We have arrays, strings, primitives. So if you know Node.js, it's very easy. If you know JavaScript, it's very easy to get started with Node. It could take you just like a weekend. But Node is not triple equals browser. So there are a few differences. We will talk about them. For example, there is no window object. Obviously, there is no windows when we work with Node.js, right? But there is global. So if you're just working with browser JavaScript, think about global as a window. It's kind of everywhere. It's kind of magical. And then it has properties. By the way, the property is also accessible without the prefix, without global dot. So I can just say underscore underscore dear name, for example. It would work. So all the properties of global, they're also kind of global in themselves. So file name would give me the path, an absolute path to the currently running script. The dir name would also give me the path, but without the file name. So we don't have that in the browser, right? You don't want to navigate the websites, and you don't want the websites to know your file system, what folder you're running the script from. But on the server, it's a completely different picture. We have that extra information. Another thing we don't have in the browser JavaScript is modules. So modules are native in Node.js. The way we work with them, we have module to export, and then we have required to import modules. It's started from the common JS web standard, the browser standard, but now it's more or less the standard for Node.js. Some of the other useful things that we can do with Node, which we cannot do with the browser JavaScript. Process or global.process. It will give you a lot of information about the underlying Node.js process and your machine. For example, you can get the process ID. You can get the versions, not just the version of Node.js, but the version of the V8 engine, for example. You can get the architecture, if it's Windows or if it's some of the POSIX systems. If you're building a command line tool like Webpack or Grunt, you can get those options and command line arguments inside of your Node process. We can get environmental variables, things like API keys, passwords, etc. Can get the uptime and current memory usage from the machine as well. And CWD, that's very similar to the dir name, but only if you're running your Node program from the same file, from the same folder, from the same directory in which you have the source code. So in some cases, this value would be different. And then we can exit the current process, and we can also terminate other processes. That comes in handy when we're scaling, when we're using clusters. Okay, so this is a tricky question. So who likes and understands callbacks? Okay, it's like 40%. What about callback hell? Once in a while, we might get ourselves into this mess, right? So developmental scalability, that means bringing more people, more developers to current projects, having more people work on a single piece of code. And callbacks, they're not very developmental scalable. That's how I feel sometimes. I'm working with callbacks. So there are other patterns like promises and async await and generators, but they don't solve all the problems. They solve some of the problems that callbacks have. But what if you, for example, want to execute something many times, and you want to execute that not just at the end, like with callbacks or promises, but you want to execute it in the middle or in the beginning of a job or a process. So please meet events or event emitters. They're a singleton pattern, not a singleton, they're observer pattern. So Node.js observer pattern. A good thing about events, they're everywhere in the core Node.js modules. So if you know how to work with events, you would understand how to work with pretty much all of the core modules of Node.js. So we have our subject, we have an object, and then we have event triggers, right? So we have three things working together. So to create an object, all we need to do is require events. And then we're using prototypal inheritance to create an object. And then we can attach event listeners. So for example, I want to listen for the done event. A good thing about event listeners, unlike callbacks or promises, is that we can have multiple pieces of logic executed on a single event. So for example, knock, it's a single event, but I can have many functionality executed. And the order in which it will be executed is the same order in which I define them. Now, this is a very basic example, so let's see something more real life, something more realistic. So let's say I have a job, which is like a job to send emails. And then I have three different types of emails: monthly, weekly, and daily emails. So I want to implement the job module the way that I can customize what is happening at the very end. So my job module will emit an event, job.emit. And then when I'm using this module, when I'm actually consuming, now I want to put that custom logic. And the way I do it by creating an event listener. So I know my module is emitting this event. I know the name is done, D-O-N-E. So all I need to do is put an event listener. The good thing compared to just callbacks, if I don't specify this event listener, it's not going to crash, right? If you don't specify a callback and your module expects it, right? So the module will crash. Another thing is that I can remove event listeners. I can get the list of event listeners. I can have many of them, not just a single. Callbacks is typically just a single callback. Highly recommend this book, Node.js Patterns. Oh, it's not a book. Okay, it's just a blog post. I'll have the link to the book later. Okay, so the next problem is how to handle large data. So if you're working with files larger than 1 gigabyte, you might hit the buffer limit. And it's just not a nice experience to wait for the entire large data to load. So please meet streams. They are abstractions to allow us to work with continuous chunking of data. So we don't need to wait for the entire large chunk of data, piece of data to load. So there are 4 types of streams: writable, readable, then the duplex, which are both readable and writable, and then the transform streams. So streams inherit from event emitters. So we will be using the knowledge which we just acquired in the previous slides to work with event emitters. So streams, they're pretty much in a lot of places. The HTTP request and response, they're streams. When we're reading from standard input and output, those are streams as well. When we're working with files, they're streams. Example of a readable stream, process.stdin. There is a read operation. So this example will capture me typing on a keyboard, and my program will output whatever I'm typing. So line by line. So for each line, I would have the console log chunk colon output me the previous line. You can run this demo on your computers if you're following along. Now, streams has another approach which you can also use. So readable.read, it's a synchronous method which returns the current chunk of data. And once the stream is finished, it will return null. So we can put it in a while condition. So when it's null, the while will stop working. And it's okay that it's synchronous because each chunk is just a line of data if we're reading from a file, working with the text data. So it's not a big deal. In this case, it's synchronous. What about writable streams? So there is a write operation. So the next example will write an output to a terminal. It's actually very similar to what console.log is using under the hood. So what about HTTP? So when we're working with HTTP, that's where streams are really, really beneficial because now your clients, they can start receiving the data right away. Or if you're consuming the data, you can transform the data right away. So in this case, we're using event emitters, and we're listening for the data, which is coming from the request. And then I have this function transform. Let's say it's a transform stream. And maybe I'm writing this data somewhere or just transforming it. So it's very, very useful. Another interface using .pipe. It's very similar to Linux command line. So you can pipe from one process to another, or in this case, from one stream to another. So to work with binary data in Node.js, there is a type called buffer. In ES6, they're also in ES6.7, they're also adding this similar, but so far it's not as popular on the browser JavaScript. So think about buffers as the binary type. And when you're working with file systems or even working with HTTP servers, by default, the data it's in buffer. So if you see a weird string that's supposed to look like a normal text, but it's a bunch of numbers, looks like an array, probably you need to convert it from a buffer to a string. To do that, you can use a toString and then pass an encoding. So FS module, by default, the data is a buffer. And I have an example of a server, Express server, which uses two endpoints, one with streams, another without streams. Once you start it, you can go to /stream and /stream /non-stream, non-stream, and you would see the difference. In my case, the response time was way, way faster for the stream endpoint. And I have the large picture, I have 8 megabyte infographic. So that's noticeable. Some of the cool stream resources. Highly recommend Stream Adventure and Stream Handbook. It's all open source, free to use and view. If you know streams, you pretty much can become like a guru of Node.js in your team, maybe even in your company, if your company is not big. So back to scaling, how we can scale Node.js, because remember, it's single-threaded, right? And this is one of the arguments which you might hear from your coworkers, from hardcore Java developers, like, oh, Node.js is single-threaded, we cannot use it. Well, actually, it's relatively easy to scale Node.js. What we can do, we can have one master process, and then we can have multiple worker processes. So the master will be just creating new workers and listening when those workers are dying or crashing to restart them. And then the workers, they would be actually doing all the heavy lifting. They will be doing all the processing. They would be our HTTP servers. So the good thing about this core module, cluster, it's a core module. Well, that's a good thing, probably the only good thing. So there are better alternatives. I have an example as well. I'm using load test, so you can load test your server with cluster and without the cluster. So other alternatives are strong cluster control and PM2. A lot of developers like PM2. PM stands for Process Manager. So basically, you can use PM2 or a similar tool without anything else, just like that. And your application would be really, really good and robust in production. So that's when you want to scale and go to production. My personal favorite thing about PM2 is that you don't need to modify your source code. So you just use the source code exactly the same as for the single process. PM2 will create multiple processes and utilize the maximum CPU power from each machine. So that's vertical scaling. I have some demos as well in the source code, so you can play with that. There are multiple ways to start a different process, not just fork. So fork is mostly for Node.js, and then we have spawn, which is pretty much for anything. They work very similarly. You can process big data, large data with both of them because they use stream. And exec it does not use stream. It uses just a callback, so you don't use event emitters. And obviously, if it uses a buffer, you will run into buffer limit. So usually exec is for small commands. Here's an example, spawn Node.js program.js. So I can run a different Node.js instance. Fork, very similar, only I don't need to specify that it's Node. So it's only going to work with Node processes. And exec example, I have a callback. So in the callback, I would get std out, std in, std error from that process. Okay, so asynchronous errors. They're a little bit tricky because remember that event loop from the first slides? So actually what happens when we use event loop, we'll lose the context. So this is how you would handle errors in traditional languages and asynchronous errors in JavaScript. We would put try catch. But try catch totally useless when it comes to asynchronous code, because that event loop, when it schedules something in the future, it loses the contents, it loses the try catch. So when the callbacks comes back, we don't have that try catch anymore. So this will fail miserably. And this is how I feel when I work with and try to debug asynchronous errors. I promise this is the last GIF. So how to deal with this? There are multiple things that are considered the best practice. I would not go into details about all of them, but I think the most important one is uncaughtException. So process, remember process? How many of you remember process? Okay, that's a good ratio. Half of the room, another half was already sleeping. UncaughtException. So process.on uncaughtException. This is how we attach an event listener. So again, process implements event listener and event emitter pattern. Why this is good? Because this is like the last step before application crashes. So we definitely want to listen to this error handler, to this event. We want to log it. We want to maybe send an email or a Slack notification, and then we want to exit gracefully. So we don't want to resume the application because the state might be lost at this point. Okay, here's the domain, which is softly deprecated. nothing scary about self-deprecation. It just means they're going to remove it from the core, but I'm sure it will be like a standalone NPM module. The way it works, we can put code inside of the main.run, and even it's asynchronous code, it will still catch those errors. It will still catch those asynchronous errors. So if you're building an Express server, you can wrap all middleware, all routes in the main.run, or you can just wrap a single route. I have a few examples in the source code folder as well. So this code will run okay. And then the bonus part, we 3 minutes over the time, so I will move a little bit faster. It's about writing the C++ add-ons. So a lot of people think that Node.js is just JavaScript. Well, actually, there is more C and C++ in Node.js itself, in the platform itself, than JavaScript. And it's very, very straightforward how to make them work together if you want to write a module or a driver to your database or maybe some hardware device. So all you need to do is have a C++ file, obviously, right? It's not going to work if you don't have the source code. And then notice this thing. So this thing will output a string, and then I'm exporting my method. So you need to do two things inside of your C code. You need to, well, write your code, right? And then expose it as the method. And then I'm creating this JSON file, which has the name of my add-on, the name of my library, and my source code. I'm installing Node.js, which will do the compilation, and run these two commands, configure and build. And that's it, boom. I would have this folder, build release. Now from the node, all I'm doing is just requiring this folder, and I can use my method. So hello, that's the same method that I defined and exported in C++. So that would output capital 1 when I run it. So you can basically communicate between two worlds, two different languages. I think that's pretty cool. If you want to hear more about Node.js at Capital One, we are top US bank. There is a YouTube video and a 30-second summary. We'll make it like 3-second summary. So event emitters, streams, clusters, domain, C++ add-ons, and streams. So the slides on GitHub. Just search my name and also find it. You can reach me on Twitter. And if you want to learn more, Node University, I would have this talk available there for free, all open source, as an online course, and also I have a bunch of other online courses on Node.js as well. One last thing, this is a quote from codinghorror.com. JavaScript is everywhere, and it could be a good thing or it could be a scary thing. If you think about Tesla running on JavaScript, but if you think about Terminators running on JavaScript, maybe humanity will have a hope. Thank you, everyone. Enjoy the conference.